The following outline is provided as an overview of and topical guide to software engineering. Software engineering, application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software, that is the application of engineering to software, technologies and practices. Skilled software engineers use technologies and practices from a variety of fields to improve their productivity in creating software and to improve the quality of the delivered product. Software applications. Software engineers build software that people use. Applications influence software engineering by pressuring developers to solve problems in new ways. For example, consumer software emphasizes low cost, medical software emphasizes high quality, and internet commerce software emphasizes rapid development. Business software, accounting software, analytics, data mining closely related to database decision support systems, airline reservations, banking, automated telemachines, check processing, credit cards, commerce, trade auctions, reverse auctions, barcode scanners, compilers, parsers, compiler optimization, interpreters, linkers, loaders, communication, email, instant messengers, VoIP, calendars, scheduling and coordinating, contact managers, computer graphics, animation, special effects for video and film editing, post-processing, cryptography. Databases support almost every field. Embedded systems. Both software engineers and traditional engineers write software control systems for embedded products. Automotive software, avionics software, heating, ventilating and air conditioning software, medical device software, telephony, telemetry. Engineering. All traditional engineering branches use software extensively. Engineers use spreadsheets more than they ever use calculators. Engineers use custom software tools to design, analyze, and simulate their own projects, like bridges and power lines. These projects resemble software in many respects, because the work exists as electronic documents and goes through analysis, design, implementation, and testing phases. Software tools for engineers use the tenets of computer science, as well as the tenets of calculus, physics, and chemistry. Computer-aided design, electronic design, automation, numerical analysis, simulation, file FTP, file sharing, file synchronization, finance, bond market, futures market, stock market, games, poker, multi-user, dungeons, video games. Information systems support almost every field. List management of laboratory data, mismanagement of financial and personnel data, logistics, supply chain management, manufacturing, computer-aided manufacturing, distributed control systems, music sequences, sound effects, music synthesis, network management system, element management system, operations support system, business support systems, networks and internet domain name system, protocols, routers, office suites, word processes, spreadsheets, presentations, operating systems, embedded graphical multitasking, real-time, robotics, signal processing, encoding and interpreting signals, image processing, encoding and interpreting visual information, speech processing, text recognition, handwriting recognition. Simulation supports almost every field. Engineering. A software simulation can be cheaper to build and more flexible to change than a physical engineering model. Sciences. Genomics, traffic control, air traffic control, ship traffic control, road traffic control, training, drill simulation, testing. Visualization supports almost every field. Architecture, engineering, sciences, voting, World Wide Web, browsers, servers. Software engineering topics. Many technologies and practices are confined to software engineering, though many of these are shared with computer science. Programming paradigm, based on a programming language, technology, object-oriented programming, aspect-oriented programming, functional decomposition, structured programming, rule-based programming. Databases, hierarchical, object relational, SQL, XML, SQL, MySQL, NoSQL, graphical user interfaces, GTK plus GIM toolkit, WX widgets, Ultimate++, Qt toolkit, FLTK, programming tools, configuration management and source code management, CVS, Subversion, Git, Mercurial, ACS, GNU, ArchLib, Source Synchronizer, build tools, Make, Cabal, AntCades, Nant, Maven, Final Builder, Gradle, Visual Build Pro, editors, integrated development environments, text editors, word processors, parser creation tools, YACC, Bison, static code analysis tools, libraries, component-based software engineering, design languages, unified modeling language, patterns, document many common programming and project management techniques, anti-patterns, patterns, processes and methodologies, agile software development, crystal clear, extreme programming, lean software development, rapid application development, rational unified process, Scrum, heavyweight cleanroom, ISO, IEC 12207, software lifecycle processes, ISO 9000 and ISO 9001, process models, CMM and CMMI, Scampi, ISO 15504, meta models, ISO, IEC 24744, SPEM, platforms. A platform combines computer hardware and an operating system. As platforms grow more powerful and less costly, applications and tools grow more widely available. Brew, Cray supercomputers, DEC mini computers, IBM mainframes, Linux PCs, Mac OS and Mac OS X PCs, Microsoft Net, Palm PDAs, Sun Microsystems, Solaris, Windows PCs, Symbian OS, other practices, communication, method engineering, pair programming, performance engineering, programming productivity, refactoring, software inspections, code reviews, software reuse, systems integration, teamwork, other tools, decision tables, feature, user stories, use cases, computer science topics. Skilled software engineers know a lot of computer science, including what is possible and impossible, and what is easy and hard for software. Algorithms, well-defined methods for solving specific problems, searching, sorting, parsing, numerical analysis, compiler theory, YACC, Bison, data structures, well-defined methods for storing and retrieving data, lists, trees, hash tables, computability, some problems cannot be solved at all, list of unsolved problems in computer science, halting problem, complexity, some problems are solvable in principle, yet unsolvable in practice, NP, completeness, computational complexity theory, formal methods, proof of correctness, program synthesis, adaptive systems, neural networks, evolutionary algorithms, mathematics topics. Discrete mathematics is a key foundation of software engineering. Number representation, set, bags, graphs, sequences, trees, graph, logic, deduction, first-order logic, higher-order logic, combinatory logic, induction, combinatorics, other domain knowledge, statistics, decision theory, type theory, life cycle phases, development life cycle phase, requirements gathering, analysis, software architecture, computer programming, testing, detects bugs, black box testing, white box testing, quality assurance, ensures compliance with process, product life cycle phase and project life cycle, inception, first development, major release, minor release, bug fix, release, maintenance, obsolescence, release, development stage, near the end of a release cycle, alpha, beta, gold, master 1.0, 2.0, software development lifecycle, waterfall model, structured programming and stepwise refinement, SSADM, spiral model, iterative development, V model, agile software development, DSDM, chaos model, chaos strategy, deliverables. Deliverables must be developed for many shape projects. Software engineers rarely make all of these deliverables themselves. They usually cooperate with the writers, trainers, installers, marketers, technical support people, and others who make many of these deliverables. Application software, the software, database, schemas and data, documentation, online and or print, fact readme, release notes, help for each role user, administrator, manager, buyer, administration and maintenance policy, what should be backed up, checked, configured, installers, migration, upgrade from previous installations, upgrade from competitors' installations, training materials, for each role user, administrator, manager, buyer, support info for computer support groups, marketing and sales materials, white papers, explain the technologies used in the applications, business roles, operations users, administrators, managers, buyers, development analysts, programmers, testers, managers, business consulting, customization and installation of applications, sales, marketing, legal, contracts, intellectual property rights, privacy and privacy engineering support, helping customers use applications, personnel, hiring and training qualified personnel, finance, funding new development, academe, educators, researchers, human resource management, hiring, getting people into an organization, training, evaluation, project management, goal setting, customer interaction, estimation, risk management, change management, process management, software development processes, metrics, business topics, quality programs, Malcolm Baldrige National Quality Award, Six Sigma, total quality management, software engineering profession, software engineering demographics, software engineering economics, CCSE, history of software engineering, software engineering professionalism, ethics, licensing, legal, intellectual property, consumer protection, history of software engineering. Main article, History of Software Engineering Pioneers. Many people made important contributions to SHE technologies, practices, or applications. John Backus, Fortran, First Optimizing Compiler, BNF, Vic Basili, Experience Factory, FL, Bauer, Stack Principle, popularized the term software engineering. Kent Beck, Refactoring, Extreme Programming, Pair Programming, Test-Driven Development. Tim Berners-Lee, World Wide Web. Barry Boehm, SHE Economics, COCOMO, Spiral Model. Grady Booch, Object-Oriented Design, UML. Fred Brooks, Managed System 360 and OS 360. Wrote The Mythical Man Month and No Silver Bullet. Larry Constantine, Structured Design, Coupling, Cohesion. Edgar Dijkstra, wrote Notes on Structured Programming, a discipline of programming and go-to-statement considered harmful, Algorithms, Formal Methods, Pedagogy. Michael Fagan, Software Inspection. Tom Gilb, Software Metric, Software Inspection, Evolutionary Processes. Grace Hopper, The First Compiler, COBOL, Nanoseconds. Watts Humphrey, Capability Maturity Model, Personal Software Process Fellow of the Software Engineering Institute. Jean Beyer, Ada, Michael A. Jackson, Jackson Structured Programming, Jackson System Development. Bill Joy, Berkeley Unix, Vi, Java. Brian Kernighan, C and Unix. Donald Knuth, wrote The Art of Computer Programming, TeX, Algorithms, Literate Programming. Bertrand Meyer, Design by Contract, Eiffel Programming Language. Peter G. Newman, Risks Digest, ACM Sigsoft. David Parnas, Module Design, Social Responsibility, Professionalism. David Pearson, Computer Scientist. Developed the ICL-CADE software engineering system. Jeff Ruskin, developed the original Macintosh GUI. Dennis Ritchie, C and Unix. Winston W. Royce, Waterfall Model. Mary Shaw, Software Architecture. Richard Stallman, founder of the Free Software Foundation. Linus Torvalds, Linux kernel, free software, open source development, will trash, reuse, ACM software engineering notes. Gerald Weinberg wrote The Psychology of Computer Programming. Jeanette Wing, formal specifications. Ed Jordan, structured programming, wrote The Decline and Fall of the American Programmer. See also List of programmers, list of computer scientists, list of software moguls. Disasters. Software has played a role in many high-profile disasters. Ariane 5 Flight 501, Mars probe, Denver International Airport, Taurus, UK share settlement system and dematerialized central share depository. THERAC-25, a radiation therapy machine responsible for 6 overdoses due to faulty software. Airbus A320. The Airbus A320, while was controversial in software engineering circles, being the first civilian fly-by-wire aircraft. In the Airbus flight control systems, the computer has the final say on all decisions, meaning the safety of passengers depends upon the accuracy of the software specification, and the competence of the engineering teams producing the software stacks. The Strasburg A320 crash of January 21, 1992 is partially related to software in that poor user interface design was a contributing factor. Failure at Dhahran, Patriot missile clock issue. Notable publications. About Face. The Essentials of User Interface Design by Alan Cooper. About User Interface Design. ISBN 0-7645-2641-3. The Capability Maturity Model by Watts Humphrey. Written for the Software Engineering Institute, emphasizing management and process. The Cathedral and the Bazaar by Eric Raymond. About open source development. The Decline and Fall of the American Programmer by Ed Jordan predicts the end of software development in the U.S. ISBN 0-13191958-X. Design Patterns by Eric Gamma, Richard Helm, Ralph Johnson, and John Vlissides. ISBN 0-201-63361-2. Extreme Programming Explained by Kent Beck. ISBN 0-321-27865-8. Go-to Statement Considered Harmful by Edgar Dijkstra. Internet, Innovation and Open Source, Actors in the Network. First Monday article by Ilka Tuomi. Source: The Mythical Man Month by Fred Brooks. About project management. ISBN 0-201-83595-9. Object-Oriented Analysis and Design by Grady Bush. ISBN 0-8053-53402. Peopleware by Tom DeMarco and Tim Lister. ISBN 0-932633439. The Pragmatic Engineer versus the Scientific Designer by E. W. Dijkstra. Principles of Software Engineering Management by Tom Gilb. About evolutionary processes. ISBN 0-201-19246-2. The Psychology of Computer Programming by Gerald Weinberg. Written as an independent consultant, partly about his years at IBM. ISBN 0-932633420. Refactoring. Improving the Design of Existing Code by Martin Fowler, Kent Beck, John Brandt, William Opdyke, and Don Roberts. ISBN 0-201-48567-2. The Pragmatic Programmer. From Journeyman to Master by Andrew Hunt and David Thomas. ISBN 0-201-61622-X. See also, Important Publications in Software Engineering and CS. Software Engineering, in different languages. In Arabic, software engineering is called Handestaldmuyat. In Catalan, software engineering is called Enginyeria del Software. In Chinese, software engineering is called Ruanqian Gongcheng. In Danish, software engineering is called software engineer. In Dutch, software engineering is called software ontwikkeling. In French, software engineering is called génie logiciel. In Persian, software engineering is called mohandisi namafzar. In German, software engineering is called software technik. In Hebrew, software engineering is called. In Icelandic, software engineering is called hugbunarþarfakfríði. In Italian, software engineering is called ingegneria del software. In Korean, software engineering is called. In Malay, software engineering is called kehuruteran perishan. In Norwegian, software engineering is called programveruitvikling. In Polish, software engineering is called inżynieria oprogramowania. In Portuguese, software engineering is called engenharia de software. In Spanish, software engineering is called engenharia de software. In Turkish, software engineering is called yazılım mühendisliği. In Urdu, software engineering is called. In Greek, software engineering is called tau epsilon chi nu omicron lambda omicron gamma iota alpha lambda omicron gamma iota sigma mu iota kappa omicron epsilon. Related fields: computer science, information technology, traditional engineering, computer engineering, electrical engineering, software engineering, domain engineering, information engineering, knowledge engineering, user interface engineering, web engineering, arts and sciences, mathematics, computer science, information science, application software, information systems, programming, systems engineering.